An interval in music is the difference in pitch between two sounds. Pitch is how high or low a note is perceived to be. It's not quite the same thing as frequency because it involves the senses. It's a psychological, at least a partly psychological thing, whereas frequency is something you can measure and put a number to. But for our purposes here, we don't need to worry about this distinction. We'll be looking at how intervals work and how they're named. So here's our keyboard, and I'm going to be focusing on the range from this C to this C. Now this C here is middle C because it lies just about in the middle of a piano keyboard. It's also called C4 in scientific pitch notation. So if this is C4, then the C that's immediately below it, this one, is C3. They're an octave apart because there are 8 notes in the major scale in going from one to the other. So 1, 2, 3, 4, 5, 6, 7, 8 is an octave. Now, in terms of frequency, what does that mean? The frequency of this C here is 130.81 Hertz, cycles per second. In other words, the sound that you're hearing from that note vibrates back and forth 130.81 times a second. What about C4? It vibrates with a frequency of 261.63. Now, if your mental maths is reasonably good, you'll have noticed that that number is twice that number. So the frequency doubles when we go from one note to the note that's an octave higher than it. What about the notes that are in between? What about this note, for instance? So this is the C sharp, C3 sharp. And going from there to there, the frequency increases. It increases to 138.59 Hertz. Now, what does that mean in terms of the frequency ratio? In other words, if I divide this number by this number, what do I get? Well, let's have a look. On the calculator, we'll do 138.59 divided by 130.81. And what do we get? 1.0595. Okay, now remember that number, 1.0595. Because what we're going to do now is look at the frequency of the next note up, which is the D, and it has a frequency of 146.83 Hertz. So let's do that same calculation again, but this time with these two notes, or the frequencies of these two notes. So I'm going to divide 146.83, the frequency of D3, by 138.59, the frequency of C3 sharp, and I'm going to get 1.0595 again. Now let's move on to the C4, the middle C, and look at the note that's immediately below that, which is the B, the frequency of which is 246.94. And I'm going to do that same calculation again, involving these two numbers. So I'm going to put in the frequency of the C, divide it by the frequency of the B, and lo and behold, I get that same number again, 1.0595 approximately. Well, what's so magical about that number? Why is it that every time I divide the frequencies of two successive notes on the keyboard, I get this same number? So in going from this C, the C3 to the C4, how many steps do I have to go through if I include all of the notes? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 brings me back to the next C. So let's put our magic number 1.0595, and what I'm going to do now is multiply that number by itself 12 times, because that's how many intervals I have between going from this C to this C. Now I could, type 1.0595 times 1.059 and do that 12 times. There's an easier way of doing it. I've entered that number in there, and I'm just going to raise it to the power of 12. So that does it in a, in a shorthand way. And the answer comes out to be very nearly 2. And if I'd put in an accurate figure, I'd got these ratios exactly right, it would have been exactly 2. Well, that makes sense, doesn't it? Because we've doubled the frequency in going from there to there, and we've done it in equal amounts each time we've gone from one note to the next. This method of tuning, based on equal frequency ratios between adjacent notes, is known as equal temperament, and it's the basis of almost all Western music today. And any tuned instrument, like a keyboard, like a guitar, any instrument that is tuned will be tuned to equal temperament. And so whenever instruments are played together, even if they don't come tuned, like say a violin, which doesn't have frets on the neck, will be tuned so that it can play in tune with all other instruments. So virtually all Western music today is based on this idea of equal temperament. But there are other systems of tuning, and I've done other videos on, for example, one of the oldest systems of tuning, which is called Pythagorean tuning, and there have also been other methods of tuning throughout the ages. But today we've settled, in the West at least, on equal temperament. Okay, so now I'm going to take off my scientists and mathematicians hat, and I'm going to talk in terms of music. So the interval from here to here, we're not going to say is the ratio of that number to that number. This interval, which is a semitone or half tone or half step, is called a minor second. This is called a major second. That's called a minor third and a major third. Okay, so if you think in terms of a diatonic scale, which includes 7 notes from the root note, 1, 2, 3, 4, 5, 6, 7, and then back to the same note but an octave higher. So that's 1, 2, 3, 4, 5, 6, 7. So there's the 2, so that's the minor second, the major second, the minor third, the major third. So you might be thinking, okay, well the next one's going to be a minor fourth. But no, we call this note a perfect fourth. I'll come back and explain, or partly explain, why that's called a perfect fourth in a moment. The next note we call an augmented fourth, because it's raised up from the perfect fourth. So an augmented fourth, or we could call it a diminished fifth. There's also another name for it called tritone, and I've done a video on the tritone. It's a very, very interesting note in musical history. Moving on. So that gap there, that interval there, that's a perfect. So we've got another perfect note. That's the perfect fifth. And we have the, now we go back to the minor and majors again. Minor sixth, major sixth, minor seventh, major seventh, and back to the octave. So very briefly, why perfect fourths and fifths? But we don't use that term for any of the other intervals. Think about the diatonic scale in C, C, D, E, F, G, A, B. We've got 5 major seconds, C, D, D, E, F, G, G, A, B, and 2 minor seconds. We've got 3 major thirds, 4 minor thirds, and we've also got major and minor versions of the sixths and sevenths. But apart from the tritone, which is an oddball in itself, there's only one kind of fourth and one kind of fifth. They only come in unmodified versions, and that's why we call them perfect. So one of the things that we need to learn in music theory is these intervals, and to be able to recognize them, and even to be able to sing them. It's easier in some cases than others. Some of the intervals are quite easy to get, and others are really quite tricky. So let's go through them and see if we can find some familiar songs that include these intervals. The first interval is the minor second, and that's actually a really tricky interval. These small intervals are hard to pitch. So where have you heard that before? Yeah? Jaws. So that's the way to remember the minor second, I think, is Jaws. The major second, Happy Birthday. There you go. We all know that song. So that's the major second, Happy Ba Ba Ba. Moving on to the minor third, that's a tricky one. Any songs spring to mind? How about Greensleeves? Alas, my love, you do me wrong. There's your minor third. Major third is an easy one. Oh, when the saints bomb, or Kumbaya, my love. There's the major third. What about the fourth? So that's that one. That's actually a fairly tricky one, I find. Well, I find a lot of these tricky personally, but that one, because I want to go to either the third or the fifth. So, you know, that one, that sounds familiar. That's quite easy. But the one in between, the fourth, is quite difficult. So what's a good song there? How about Here Comes the Bride? So we all know that song. So that's a good one to remember the perfect fourth by. Now the next one. Ooh, that's awkward. That's really tricky. So what songs use that one? Well, think about West Side Story. You know that one? Maria. Maria. And there you've got it. The augmented fourth, the diminished fifth, also known as the tritone. I've done a whole video on the tritone. It's a historically fascinating note. And it is used a fair amount in music, for example. You may recognize that if you're into rock. But Maria, or if you like, The Simpsons, The Simpsons, the same interval. Okay, so that's a couple of ways to remember that one. How about the fifth, the perfect fifth? Well, there's quite a few songs that use that. Twinkle, twinkle, little star, twinkle, twinkle. Okay, so what's next up? We've got the minor sixth. Think of any songs that use that? The one I remember for this is the saxophone solo from Baker Street. Remember that one? Bum, 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 ba, ba, bum, bum, bum. And there's your minor sixth. Okay, major sixth. That one. My body lies over the ocean. Bum, bum. And there's the major sixth. Okay, next up we have got the minor seventh. Another tricky one. Da, da. Okay, if you're a Trekkie, Star Trek fan, you might recognize it. Bum, 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 ba, ba, bum. Dum, da, 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 dum. Okay, and there's your minor seventh. What about the major seventh? That's a tricky one because it's very close to the octave. In fact, we can remember it from that classic 80s song, Take On Me. Take on me. Yeah, Take on me. And there's your major seventh. And we've got tunes for all of the different intervals in the chromatic scale. Intervals really are one of the most basic elements of music. They form the basis of scales, for example, the C major scale, as we've seen, C minor, the different scales each follow certain patterns of intervals or chords. C major triad, C minor triad, and all the extensions and additions we can make to chords in all of the different keys. All the different scales, chords, melodies and harmonies are based on these fixed intervals. Well, I hope you found this useful. Check out my other videos and please subscribe if you haven't already. And I'll see you again soon.